Approximately 66 million years ago, the Chicxulub asteroid, which was 15 kilometers wide, caused the extinction of 75% of life on Earth. In a brief period, the impact near the Yucatan Peninsula created a trench measuring 180 kilometers wide. Researchers now believe that this catastrophic asteroid likely had a companion when it struck Earth. Traces found in the recently discovered Nadir crater off the African coast suggest a more substantial event than previously thought. Scientists are now investigating what they found in this crater and how it connects to the mass extinction of dinosaurs. Welcome to SpaceVerse, your cosmic gateway to the mysteries of the universe. Join us as we delve into Earth's past and explore the likelihood of a similar event occurring in the future. Let's start. Within minutes of impact, life as it was known ceased to exist. The Chicxulub asteroid's force devastated the immediate area, creating shock waves that traveled hundreds of kilometers, rupturing the Earth's crust, igniting fires, and releasing toxic gases. Tons of rock were launched into the air while the ocean floor was thrown into chaos. Additionally, a massive tidal wave was unleashed. This catastrophic event likely led to a global mass extinction due to significant alterations in Earth's climate, including atmospheric darkening and severe cold. The extinction process typically began with the demise of plants, which is followed by herbivores that relied on these plants, and ultimately, even the carnivores. The Earth has likely experienced 5 major mass extinctions throughout its history. One such event occurred at the end of the Ordovician era around 443 million years ago, resulting in the disappearance of 85% of marine species. Researchers attribute these extinctions to climate changes and potential comet or asteroid impacts. Similar scenarios unfolded during the late Devonian period, with a 75% loss of species. Mass extinctions also took place about 252 million years ago at the close of the Permian era and 201 million years ago during the Triassic-Jurassic transition, leading to the vanishing of approximately 96% of marine species and 70% of terrestrial vertebrates. The Chicxulub asteroid, which we previously discussed, represents the most recent episode in this series. Scientists now suspect that it wasn't the sole impactor, as they have identified another crater that is also around 66 million years old, which is likely linked to the catastrophic event in Mexico. The Nadir crater, situated off the African coast, represents an interesting geological feature. The Chicxulub crater initially drew attention through aerial photographs of the Yucatan Peninsula during the 1970s. In the 1980s, researchers conducted a detailed examination of this crater, swiftly concluding that only a colossal impact could have created it, as its age, approximately 66 million years, coincided with the mass extinction of terrestrial dinosaurs. Geologists and paleontologists rapidly made this connection. However, recent discoveries have expanded our understanding. Researchers from the University of Edinburgh uncovered a new crater off the African coast while initially investigating data related to seafloor spreading, a process that contributed to the formation of the Atlantic Ocean by separating the African and American continents. Upon analyzing the data, conventional expectations of shallow sedimentary deposits on the plateau were proven incorrect. Instead, scientists encountered an unexpected find: an 8.5-kilometer wide depression beneath the seafloor with distinctive features including a nearly circular shape, a raised ridge, a prominent central bump, and structures indicating chaotic sedimentary deposits extending for many kilometers beyond the crater. Earth's craters are usually the result of volcanic collapses, salt mining processes, or impacts from celestial bodies like asteroids and meteorites. The characteristics of the Nadir crater ruled out volcanic and salt mining origins, aligning more with the attributes of an impact crater. This crater, which is positioned about 350 kilometers off the coasts of Guinea and Guinea-Bissau, boasts a diameter of only 9 kilometers and a current water depth of approximately 900 meters. Until now, this crater had received limited attention due to its coverage by 300 to 400 meters of marine sediment. Despite being smaller than the Chicxulub crater, the impact that formed it must have had significant consequences. With an age of 66 million years, this event falls within the same time frame as the Chicxulub impact. Advanced computer simulations have offered valuable insights into the formation of this crater. The impacting object that struck the Earth measured roughly 400 meters in diameter and collided with the ocean at depths ranging from 500 to 800 meters. This event led to regional devastation, including a magnitude 6.5 earthquake and the initiation of a tsunami, which reached heights of up to 900 meters as it traveled through the Atlantic Ocean. The effects of this catastrophic event likely extended across the Americas, Northern Europe, and even reached as far as Antarctica. Although the energy released by the nadir impact was less than that of the Chicxulub impact, it far exceeded the tsunami generated by the undersea eruption of the Hunga-Tunga-Hunga-Hapai volcano in January 2022. Researchers now propose a connection between impacts in Africa and Mexico. Notably, significant asteroids like Chicxulub are frequently accompanied by smaller moons, suggesting that nadir could have been such a moon of the Chicxulub asteroid. Another possibility is that the parent asteroid may have fragmented into two or more pieces due to a collision with a larger celestial body. While such occurrences were likely rare, researchers in Sweden have found evidence of a double impact around 470 million years ago, resulting in fragments striking Earth and creating the Loch Ness and Malingen craters. Alongside other similar events, Boltish, located in Ukraine, represents the third notable crater within this context. It's another impressive crater that aligns with the era of the dinosaur mass extinction. Situated to the northwest of Kiev, this crater spans a width of 24 kilometers and was uncovered in 1996. At that time, it was believed to have formed approximately 65.4 million years ago. However, it's entirely plausible that the Boltish asteroid's impact coincided with those of the Chicxulub and Nadir asteroids. These impacts may have been remnants of a sequence of bombardments resulting from disturbances in the primary asteroid belt positioned between Mars and Jupiter. During these disturbances, several asteroids within the main belt may have collided, subsequently propelling fragments towards Earth. Typically, when asteroids approach Earth, they are entirely disintegrated upon impact, making it impossible today to locate rock fragments from these impacts and draw conclusions regarding their origins or whether they were parts of a much larger asteroid. Following the Boltish impact, there were likely tsunamic waves affecting the Baltic and North Seas, along with fires and significant climate changes that had a profound impact on the environment and the evolution of life during that period. When can we anticipate the arrival of the next significant asteroid? Given the wealth of data and imagery available, it's natural to ponder the possibility of events of such magnitude recurring. On average, asteroids or comets with a diameter of nearly 50 meters, which can be considered hazardous, collide with Earth approximately every 900 years. In contrast, impactors exceeding 1 kilometer in size with the potential for global catastrophe strike Earth on average every 100 million years. The most recent major impact occurred a little over a century ago when a massive aerial explosion shook Tunguska, Siberia in 1908. Due to its remote location, there were limited eyewitness accounts, but the extensive devastation and traces left behind point to an asteroid as the cause. Thousands of square kilometers of forest were obliterated. The last devastating impacts of note were those in Yucatan, off the coast of Africa and in Ukraine. It's entirely possible that there have been other impactful events that remain undocumented. Presently, only 15 to 20 extreme impact events have been confirmed worldwide. Given that much of Earth's surface is covered by water, the possibility exists that numerous large asteroids have crashed into the oceans, triggering massive tidal waves. Fortunately, NASA and other organizations continuously monitor all near-Earth flying objects and main belt asteroids. The encouraging news is that the majority of known near-Earth asteroids do not pose an imminent threat. Asteroids that approach Earth are typically categorized as potentially hazardous if they meet specific criteria including size and proximity to Earth. An example of such an asteroid is Apophis, which is expected to come close to Earth several times in the next few decades. Current calculations provide no cause for alarm, as an impact is not anticipated for the next 100 years. A similar situation applies to the asteroid Bennu, which regularly passes Earth at a short distance but is not expected to impact in the near future. Advancements in technology for detecting and monitoring potentially perilous celestial bodies are ongoing. This progress enhances our ability to respond promptly to potential threats. The scientific community is actively engaged in the study of asteroids and comets, ensuring that we are prepared to divert dangerous objects from their collision course and protect ourselves effectively in case of an emergency. On the whole, the situation within our solar system has significantly stabilized since the impacts that occurred 66 million years ago. During the early days of the solar system, Earth was subjected to more frequent asteroid, comet, and small planetoid impacts. Currently, most of these objects are safely located between Mars and Jupiter, as well as within the Kuiper belt at the solar system's edge. This stability can largely be attributed to the gravitational influence of the gas giant Jupiter, which prevents most asteroids from behaving as unpredictable projectiles within our system. Nonetheless, it's crucial to recognize that we are never entirely shielded from unforeseen events. Smaller asteroids have made their presence known in recent years. In some instances, such as a smaller rock exploding over Greenland, the resulting damage was relatively minor. However, the asteroid that detonated over Chelyabinsk in 2013 caused significant disruption in the city, despite breaking into thousands of fragments while still in the atmosphere. Although smaller asteroids and comets may not be as conspicuous on scientists' observation screens, future advancements in this field hold the promise of improved detection and understanding. Now, the question arises: can we truly consider ourselves secure on Earth, or should we brace for unpleasant surprises from the cosmos in the days to come? And that's a wrap for today's cosmic journey. Thank you for joining us on SpaceVerse. If you enjoyed exploring the universe with us, don't forget to give us a thumbs up and share this video with your fellow stargazers. See you on our next video.